Picking up where we left off. Okay, we're on number 3 now. We have 7 over 56. So now we go off to the side and we take the prime factorization of 7, which happens to just be 7 because 7 is a prime number. So the prime factorization of 7 is 7. And now we take the prime factorization of 56. We know we had 2 times 28. 2 is prime, 28 is not. 28 breaks down to 2 times 14. And 14 breaks down to 2 times 7. So now, we know our numerator stays 7. Our denominator, we will have 3 2's and a 7. These 7's simplify out, and you're left with 1 over. Now 2 times 2 is 4, times 2 is 8. So it'll be 1/8. Now we go here to 56 and 84. What's good about this 56 and 84 is this here. We already had a prime factorization of 56, which was 3 2's and a 7. Now we just need the prime factorization of 84. So we could do that here. Now the prime factorization of 84, we have 2 and 42. Then we had 2 and 21. Then we had 3 and 7. So our prime factorization is 2 2's, a 3, and a 7. So we had 2 sets of 2's that simplify out and 1 set of 7's. So our final answer here is 2/3. Now, we scroll down here. It says algebraic fractions are fractions that have a variable and the numerator denominator of both. To simplify them, reduce the numerical coefficient as usual. Then write out the factors of any variables with an exponent. For example, if the fraction contains x to the 4th, write it as x times x times x times x. Can you reduce any other variables? Now we have examples. Example 1. We have 18x over 27x cubed. So first of all, let's find the prime factorization of 18 and 27. So 18 we know breaks down to 2 times 9. 2 is prime, 9 is not, and 9 breaks down to 3 times 3. So we add 2 times 3 times 3. That's the prime factorization of 18. Now the prime factorization of 27. We add 3 times 9, 3 is prime, 9 is not, and 9 breaks down to 3 times 3. So for 27, we add 3 times 3 times 3. Now, we're going to do this. 18 is 2 times 3 times 3, and we bring over our x times x. Now 27 is 3 times 3 times 3, and we add x to the 3rd power here, so we'll write out x times x times x. Now we simplify. They have 2 sets of 3's in common and 1 set of x's in common. So your numerator, you would just have 2, and your denominator will have 3 and 2 x's. So it'll be 3x squared. So our final answer here would be 2 over 3x squared. Now, we go to number 2. We would take the prime factorization of 12 and the prime factorization of 18. 12 breaks down to 2 times 6. 2 is prime. And then 6 we break down to 2 times 3. So now we have 2 2's and a 3. Now we go here to 18. 2 times 9. We know we break 9 down to 3 times 3. So we add 2 times 3 times 3. Now we substitute. We add 2 2's and a 3 for 12. And since we have b to the 3rd power, we'll write b, we'll multiply b 3 times. Now we look at the denominator. 18, we add 2 times 3 times 3. Then we add b squared, so that would be b times b. Now we simplify. One set of 2 simplify out. One set of 3 simplify out. And then with our b's, we had 2 sets of b's that simplify out. So our numerator would be 2b, and then our denominator would just be 3. Now, we scroll down here to section C. It says solve problems giving answers in simplest form. In general, mathematicians generally agree to give fractional answers in simplest form unless there is a good reason to do otherwise. From now on, always assume that you should reduce your final answer to a fraction problem to simplest form. So this is basically saying whenever you do fractions, even if the directions do not tell you to do it, you must always write them in simplest form. Now, it says 6 weeks of the 16-week semester have been completed. What fraction of the semester is over? So what we would do is, our complete semester is 16 weeks. What's over right now is 6 weeks. So we add 6 over 16. Now we can go off to the side here, do the prime factorization of 6, which is 2 and 3. The prime factorization of 16, we could break that down to 2 times 8, and then 8 breaks down to 2 times 4, and 4 breaks down to 2 times 2. So we have 4 2's here. So we have one set of 2's in common, and our final answer is 3/8. Now it says here, how many weeks of the semester are left? Okay, so now 6 weeks are completed, and it's 16 weeks. So we would take 16 minus 6, will leave us 10 weeks. Now it says what fraction of the semester is left. So we know our complete semester is 16 weeks, and we had 10 weeks left. Now we already had the prime factorization of 16, which was 4 2's, which we did in A. Now the prime factorization of 10, we know breaks down to 2 times 5. These 2 simplify out, and you would be left with 5/8. Now just take a quick moment here. If you notice, you have 3/8 and we have 5/8 here, and we're done with number 1. Now we go down here to number 2. It says getting an associate's degree requires earning at least 60 college credits. The chart below shows the number of credits Anne earned last year, her first year of college. It says A, what fraction of the credits she needs for her associate's degree did she earn during the fall semester? Now remember, she needs to earn 60 credits, so 60 would be our denominator. And then what she earned in the fall semester was 12. Now, in the previous problem, we did the prime factorization of 12, which was 2 times 2 times 3. And then we even did the prime factorization of 60, which was 2 times 2 times 3 times 5. Now, we can simplify this out. We have 2 sets of 2's and 1 set of 3. Now, in our denominator, we know it's 5. Our numerator, when everything simplifies out in your numerator, that leaves 1, because all of this is simplifying out to 1. So your final answer here is 1/5. Now we go here to B. It says what fraction of the credits she needs for her associate's degree did she earn during her first year? Now we add up all of these credits. 12 and 16 is 28, plus 8 is 36. So it's 36 over 60. Now we know the prime factorization of 60 is 2 2's, a 3, and a 5. Now for our numerator, the 36, I don't think we did the prime factorization of 36. So that's 2 and 18, this is 2 and 9, and this is 3 and 3. So we had 2 2's and 2 3's. Now, these two sets of 2's simplify out, and 1 set of 3's. So this would be 3/5. Now it says how many credits does she still need to earn? Now remember, she needs 60. She completed 36. 60 minus 36 will give her 24. Now it says what fraction of the credit she needs for her associate's degree that she still needs to earn. So now we write this in fractional form. It'll be 24 over 60. Now we know the prime factorization of 60 is 2 2's, a 3, and a 5. Now the prime factorization of 24, we have 2 and 12, and we add 2 and 6, and then 2 and 3. So we add 3 2's and a 3. Now we had 2 sets of 2's we can simplify out, and 1 set of 3's. So we're left with 2/5. And that is our final answer. Okay, now we start section 4.3, multiplying, dividing fractions. Okay, section A, multiplying fractions. Rosie decided that she was going to devote 1/3 of her yard to a flower garden. She then planted 2/5 of her garden with some beautiful pink Gerber daisies that she found. What portion of her yard is planted with Gerber daisies? Now, we're given a visual picture here. And now we will write this as a fraction. It says, notice that the product turned out as we might have expected. We have 1/3 times 2/5. Now it says here the rule for multiplying fractions is multiply the numerator, so we'll take 1 times 2 is 2. Multiply the denominators, 3 times 5 is 15. Then simplify if possible. 2 and 15 has nothing in common. Even if we did the prime factorization, this would be 2 over 3 times 5. You have nothing that simplifies out, so it'll still just be 2 over 15. And that's it for that problem. Now, we go on to our next page. And we start here with our first example. So we multiply across 3 times 5 is 15. And 7 times 6 is 42. Now we've already done the prime factorization of 15 before, which is 3 times 5. And we've done the prime factorization of 42 before, which is 2 times 3 times 7. Now we can simplify. These 3's will simplify out, and you will be left with 5 over 14. Now we go here to number 2. 7 times 2 is 14, and 9 times 3 is 27. Now we would see with the prime factorization of 14, we know it's 2 and 7, and the prime factorization of 27, which we did before, comes out to be 3 set of 3's. And we have nothing in common, so our final answer will remain the same, 14 over 27. Now, there is an easier way of doing this prime factorization. Whenever you're multiplying fractions, why don't we just do the prime factorization first? The prime factorization of 4 is 2 times 2, and 3 is already prime, so we multiply that by 3. Now the prime factorization of 9 is 3 and 3, and the prime factorization of 10 is 2 and 5. So now we have all of the prime factorization. Now we have 1 set of 2's that are in common, and 1 set of 3's that are in common. So our final answer here would be 2 in the numerator and 15 in the denominator. And that's it. Now we go to number 4. We will follow the same process. We know the prime factorization of 8 is 3 2's, and then 3 is prime, so we multiply that by 3. And our denominator, the prime factorization of 15 is 3 times 5, and we know the prime factorization of 16 is 4 2's. Now, we simplify this out. We have 3 sets of 2's that are in common, and we have 1 set of 3's that are in common. So our final answer would be negative, our numerator would be 1, and our denominator would be 5 times 2, which is 10. So it's a negative 1/10. Now looking here, we would have had to take the prime factorization of 24 over, it was what, so we would have had to take the prime factorization of 24 over 240. Now that would have been a lot more difficult to find a prime factorization of 24 and 240 instead of breaking it down like this here. Now remember, we can only do this with multiplication, nothing else. Now, with our next problem, We have a negative times a negative, so we know our final answer is